let's do this kind of backwards from the way we just did it. 0.05 alpha. What's the degrees of freedom?
5.
Good. 6 categories, so degrees from 5. So when you look up the rejection region chi-square, what do you get?
11.071.
Yeah, so here's your degrees of freedom of 5. Alpha was 0.05. So here's your 1107. Okay, so now we know where evidence starts. Dun, dun. And now, obviously, what will they expect it to be?
20.
Yeah, so I got 120 divided by 6, so they should each get 20.
Wait, can you explain that again?
Oh, okay. If you roll a die 6 times, do you expect any of the numbers to show up more than once for any particular reason?
Yes. Wait.
Which number should show up more than once?
Oh, not.
Do you see what I'm saying?
Yeah.
So
yeah.
there's no number. So if I could ask a different question, would you expect to see more than one of the numbers? Probably. I mean, right? But is there any expectation going in that any of them will show up more than the others? So therefore, the expectation is they're all the same.
Oh, okay.
So if I have 120 and there's 6 possibilities, 120 divided by 6, they should each show up. Why did it put an extra 20? I don't know. They should each show up 20 times. I like it. So anytime you have a uniform distribution, you divide the total things by the category, so you can see how much each category gets. I like it. Now the observed is easy as shit, right? You just, because it told you all those, blah, 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 so I put them in there. Okay. Yeah. And again, you don't have to use the calculator, but you can if you want to. So here, this would be L1 minus L2 squared to get my observed minus expected squared. And then I want that list, that's the observed minus expected squared, divided by the expected stuff. How are we doing out there? Is those the same? Are those the same numbers? It's not a good speaking day for me, which is bad for my job. All right, so I'm not going to fill all this in. So now I could just add up all the stuff on my L4. And I could do that very quickly like that. 4.9? Well, let's do now. All right, so how did we do? Did we make it?
No.
Damn, we're way down there, right? Shit. Yes?
So if the chi-squared is in the shaded part, we say we have found sufficient?
Yeah, and isn't that exactly the same as normal hypothesis tests, right? So if you don't make it, you didn't find evidence. And just remember, 0 means no difference. So therefore, this whole region that's on the 0 side means we can't say there's a difference. This is far enough away from that to say there is a difference. I like it. So we've not found evidence that way. I literally forgot what this problem was. Oh yeah. We haven't found evidence to say what?
The rejected claim that the dice hasn't been tampered with.
Yeah, and I would accept this. We have not found evidence to say the die has been tampered with. Right? Blah, blah, blah. Blah. Okay. So I'm not going to be overly picky about the way you say it specifically, but you have to capture the idea. We didn't find evidence to say the die has been tampered with because it wasn't different enough. And sure, I got 28 sixes, right? But even just looking at that by itself, that kind of feels like within the realm of what I would expect from just random variability. Yes, maybe? Maybe, yes. Okay. Okay. So this isn't that horrible. The only thing that makes it semi-horrible is the fact that you now have one more chart to read and to keep track of. Last thing for today is section 11.6, which is where the actual hypothesis tests live. So let me get your reaction to this. Let me see if I can make a problem. We feel the standard deviation of tests in Jeff's class, test grades. In Jeff's class is less than 16. So the only difference from a claim from like chapter 9 is I said standard deviation. I didn't say percentage is less than something. I didn't say mean is less than something. I said standard deviation is less than something. Standard deviations live in chi-square distributions, not in normal distributions. So I can't use that kind of stuff. Can somebody help me out with can you put the claim in Mathish? Can you put the claim in Mathish?
Yeah.
Yes.
Standard deviation.
Say what is it? What's this?
Hold on, that's what I'm struggling with.
Gotcha.
Sigma,
Sigma.
less than.
Less than.
16.
Holy shit. Where does that go? You know.
In the ha.
In the ha, yes. Oh, this is beautiful. Okay. So some of you guys are like, God, damn, this hypothesis shit's back, but not much has changed, really. Now, I don't think I'm going to get too picky. I don't even think the book addresses this. No. All right. So the book doesn't even address this. I'm not going to get into this because it does get a little freaky. Normally, the second thing would be, what are we allowed to use? I didn't even give us any sample information. Okay, I'll do that in a minute. So the second step we're not going to worry about. Third step is rejection region. So let me give you some specifics. So you need a couple things. So let me give us some sample data, right? Here's some sample data. From a sample of, what do you got, Jeff? Let's say 28 tests. We found standard deviation of 14.18. I like it. Kick ass. And down here I'm going to say use 0.01 for alpha. Now, are we doing a goodness of fit test? No. So we don't have categories and all that shit, yes? So degrees of freedom is back to normal, right? So what's our degrees of freedom here? 27, okay. So it's only for goodness of fit tests. And as far as we know, that degrees of freedom is calculated differently. So degrees of freedom is 27, like normal. Can you guys really quickly figure out? By the way, where will the tail be? Tail? I love it. Good Lord, Jeff. What have you done today? Okay.
Right here?
What's HA say?
Less than.
Less than.
So left.
Yeah, so it's going to be on the left. So the 0.01 is going to be here, yes? I really want you guys to understand this. Now, the way this chart is set up requires you to be more careful with your drawing. I'm not really capturing that well with my shitty little drawing, but what really matters is I put the 0.01 in the tail, so I got to know which side the tail is on to be really safe. Is that the right area to be able to use the chi-square chart? No, because it wants to the right, so of course how much is to the right? 99. All right, so let's look up this chi-square. 0.99. And what I really, does anybody notice what's really nice? Isn't this on this side? The tail is on this side, and am I not on that side of the chart also? I don't know if you guys really see what I'm saying. It's a left tail test, and sure enough, where we're looking is on the left side. Yes? That's kind of nice? Okay, maybe. So 0.99. I'm going to stop at 27. So I get 12.879 down there. Yes? 12.879. So if my chi-square star, sure went up, is less than 12.879, what can we do? If I get in here, what can we do? If we get into the rejection region, we reject what?
No.
The no. I love it. That didn't change, yes? In fact, not much has really changed yet, except we used a different chart. Now, here is where the original chi-square formula I showed you finally comes into play. This is the formula we're going to use. That's the very first formula I showed you. This is where it comes into play. So n minus 1 is 27. What's s? 14.18. What's sigma? 16. Remember that number always, mu came from the plane. P came from the plane. Sigma comes from the plane. The biggest mistake I see is forgetting to square these poor little dudes, right? I have no idea what that shit is, so somebody help me out. Stop trying to try something. Jeff, you gotta count it all in. Holy shit. That was really close. What do you guys get? 2-1 roughly? Is that right? Yeah. Did we make it far enough? Or I mean, did we show up in the right place? Let me say it that way. No, we didn't. We showed up over here. Right? So therefore, did we reject the null, or did we fail to reject the null, or what?
No, we failed.
Did we make it into the rejection region? No. So therefore, we have to fail to reject it. We didn't make it into the rejection region, right? So we fail to reject the null. We fail to support the hop. So how do I write my conclusion? What was the claim? Which one was the claim? Yeah, the ha was the claim, so we have not found evidence to support the claim. Support the claim that the standard deviation is less than 16. In Jeff's classes, blah, blah, blah. Okay. It says in Jeff's classes now. Now I understand some of us have some trauma related to remembering hypothesis tests, but at least this is not very different from that. It would be really sucky if it was a hypothesis test and it was all different. That would really suck. This feels very much the same, hopefully. Hopefully. Okay. Just like when we had Z and then we went to T, it's the same. Yeah, I love it. No. Chi-square you can do a lot more with it. So I mean, now you got the 3 big distributions that we use. There's even another one past this that we don't quite get to. And there's a lot more stuff you can do with each of them. I think I told you guys I posted the practice final, right?
Yeah.
Next week I'll make the videos of solutions available on Canvas. So go to Canvas, you can get the practice final. On Tuesday, I don't think I've said, no, all right.
Will we get a hand copy of the practice file, or will
If I remember to print some out, we'll see. All right, I'm not gonna do that to you guys. I was thinking about making a quiz on Tuesday.
You shouldn't do that.
How many people would kill me if I didn't know? They'll say you shouldn't do that. I shouldn't do that? No? Some of you guys don't realize you want more grades, but okay, I won't do that. So Tuesday, we'll do some more examples of this, and then we'll start doing we'll start doing final exam review. So we'll have like at least 1.5 classes to review for the final. Cool, all right guys.